Hi, good evening, guys. Today's topic will be collaborative filtering. We'll be going ahead. Basically, filtering is a recommendation technique that makes prediction based on the user's past behavior and the behavior of the other similar user systems. So, there are two types of collaborative filtering. First would be Actually, there are three types of. First would be user based collaborative filtering. Second is item based collaborative filtering. And third is SVD filtering. So, uh, like, basically, what is SVD filtering in collaborative filtering is like SVD filtering refers to using singular value decomposition as a technique for building a collaborative filtering recommendation system. So it basically use a powerful factorization technique used to extract latent features from a user item interaction matrix and recommendation systems. So basically, SVD, what SVD does is like it in this user gives ratings to items, for example, movie, books, and when the most of the ratings are missing, it means that users haven't rated anything. So SVD basically help us to predict those ratings in that. So you can think that like users are described using k preferences and items are described using k properties. So basically you will be predicting a user's rating for an item by taking the dot product of their vectors. So why SVD is used in collaborative filtering? First would be because of its compact representation, because it reduces high dimensional data to lower dimensions. And as you know that it is a dot product of their vectors, so it does that. And second would be it also predicts the missing values, as I have given an example that basically you can suppose there are three users, and two of the users have given rating, and there are three users, and user 3 has not given any rating. So SVD is a technique to find the missing rating. So it basically predicts the missing values, and it also can estimate how much a user might like an unrated item. And thirdly, it also captures hidden structure. It basically learns relationship, like user who likes the mat, for example, there are two movies. So one is the Matrix and the other one is Inception. So basically what SVD does is like it automatically predicts the relationship between it, and it intends to connect it. So basically it is like that users who like the Matrix also like the Inception movie, so it categorizes it into a different row. And users similar to Alice tend to dislike horror films. Basically it has made a prediction based on the historical data that was present for a user. So when you have a typically sparse matrix where rows is equal to users and columns is equal to items and values are ratings and most of the values are missing, like it means that users haven't rated most items. So the problem that is solved by SVD technique. So as you can see that this is the formula, the dot product of vectors, and for component R, users into items is there, and for U it is users into K. Like basically K is a number of latent features that are used in this user and rating features, and then sigma, that is K into K, for diagonal matrix with singular values, that is there. And in real recommendation systems, the real surprise library uses a version of SVD adapted to incomplete matrices with missing ratings. So basically, the final thoughts on SVD is that it helps us uncover hidden feature in the user item matrix. It also predicts missing ratings using only user behavior, and it avoids needing genre tags or other metadata. So the first step for this SVD would be like we need to construct the rating matrix that would be R. Then post that, step 2 would be applying the formula. As you can see that each user is a vector of two values and each movie is a vector of two values that are features, and dot products gives the predicted rating. Third would be to predict the reader ratings. So to predict user one's rating for the movie B would be the dot product of both. So suppose if the user one is 0 0.9 and 0 0.1, and the sigma value is 5.00, and VT is that movie B is this. So the predicted rating according to the formula would be 1.62. So we are simply putting all the values present into the formula that is being given by SVD, and hence the prediction is done. So the summary of SVD would be basically it decomposes user item rating matrix, and the purpose for it is there to predict unknown ratings, and the benefit of this is it captures hidden relationships, and technique that is used for SVD is matrix factorization using latent features. Now we will proceed to user based collaborative filtering. So basically, user-based collaborative filter recommends items to a user based on the preference of other users who have shown their behavior, like who have shown similar behavior. For that is who have rated or interacted with items similarly. Users who are similar tend to like similar things. For example, if user A and user B both like the same movies and user B liked another movie that user A hasn't seen, that movie can be recommended to user A. Imagine your friend both love Marvel movies. One day your friend watches the new superhero movies and gives it a 5-star rating. Based on similar preferences, the movie might be recommended to you even if you have not heard of it. So how it works is like, first we will collect the user item interaction data, that for example that would be movie ratings, purchase history, etc. Second step would be measure similarity between users using metrics like cosine similarity, Pearson correlation, and etc. Third step would be find k nearest neighbors, that would be identifying the top k users who are most similar to the target user. Fourth would be predict rating for unseen items. So basically, we are gonna estimate how much the target user would like an unseen item based on neighbor ratings. Fifth is recommend top end items. That would be suggesting the highest predicted items to the user. So this is the step by step mechanism for user collaborative filtering that uses. So this will be the formula that we'll be using for predicting rating. The step one would be user item matrix, that would consist of rows that will be equal to users, columns that would be equal to items, values would be the ratings. Then second step would be to compute user similarity by using cosine, Pearson, Zakat compare rating factors. Third step would be to find the k nearest users, most similar users to target. Step four would be to predict ratings, and like basically it is to determine to use similar user ratings weighted by similarity. Step five would be recommend top end items, that would be item with highest predicted ratings that user hasn't seen. Now we will move to item based collaborative filtering. So basically, item based collaborative filtering means it basically recommends items based on similarities between items rather than users. So basically, if item X and item Y are rated similarly by many users and the user liked item X, then recommend item Y even if the users are different. So basically, the like for an example, on Amazon, if many users who buy a Bluetooth speaker also buy a wireless earbud, then if you bought the Bluetooth speaker, Amazon recommends the wireless earbud to you based on item co-occurrence. In simple term, it focuses on finding similar items, not users. And it also finds the recommendations that are based on similarity between items rather than user behavior. So the workflow steps for this would be, first would be the input, as we'll get user item ratings matrix. Then second step would be for this finding similar items, that would be the compute step, compute similarity between items using ratings across users. So third step would be select neighbors for each item rated by the user or find the similar items. Fourth would be score candidates, score items based on weighted sum of similarity and rating. Fifth would be recommendation, that would to recommend top and similar items that has not been rated yet. So this will be the predict the rating for unrated item. This will be the formula that we'll be using for this predicting thing. So this is the flow chart for this. So basically, as I've described, first would be to find the user item ratings matrix. Second would be the compute item similarity step. Third would be the select target item for recommendations. Fourth would be to find similar items, that would be top and recommendations. Then, sorry, no, it will be find similar items, that will be top n. Then it would be to score items based on similarities and user ratings. Last step would be to recommend top n items with highest score. So the pros of item based collaborative filtering would be that it is more stable because items change less than users. It also has better performance on large user set, easy to cache similarity, because it you like, and the cons for this would be like it needs enough item ratings, and it also requires cold start for new items, and it also ignores user context and preferences. So basically, in real world cases would be in Amazon, like customer who bought this also bought this. I have already given an example on that. If many users who buy a Bluetooth speaker also buy a wireless bud, then if you bought the Bluetooth speaker, Amazon recommends a wireless bud to you based on item co-occurrence. So when to use item based filtering? Basically, when there are many users, stable item catalog, because items don't change much over time. High sparsity in user item matrix, because item similarity is more stable than user similarity. Real time recommendation is needed, then pre compute item similarities can be done. And cold start for new user, because it is still possible to recommend items based on what items user has interacted with. So this is the logic that we'll be following. Okay, now we'll proceed to the examples. First, we'll be doing the example for SVD. So, uh, so we are using a data set that is movie lens 100K data set. So then we are splitting into training and testing sets. Then we are initializing the SVD model. Then we are moving forward to train the model. And now, like in the fifth part, now we need to make the predictions on the test set. And then we need to evaluate the performance. So basically, this is the output that we are getting. So the format of each line is that first is the user ID, the unique ID of the user in the data set, and followed by item, the unique ID of the item being rated up, that is a movie. And the actual rating that the user gave this to an item, that is the ground truth from the data set. And predicted is the rating that is predicted by your recommendation algorithm. First is user 907 rated item 143 with a perfect score of 5.0. But the model predicted 4.61, which is quite close, indicating a good prediction. Second is user 733. In this, user gave a very poor rating, one, but the model predicted a much higher rating, that is 3.17. This is a poor prediction, likely a misjudgment in taste or item similarity. So this is how it goes. Like the actual rating, if the predicted value is differing, then so if the actual rating is differing from the predicted value, then the model is making some mistakes. So as you can see, the output actually is 5 but predicted 4.80, but still it is somehow close to 5, still a good one. But in this, as you can see, that actually is 2.0, but it has predicted 2.88. That is not nearby close to the actual rating. So it is not a good prediction that the model has made. So basically, this is how it is done. Please go through the codes once, and like I will just.
Ma'am,
Sorry.
ma'am, I have a question.
Yes.
The example that you gave, where the actual value was much higher than the predicted value, or
Yes.
sorry, lower. So it can be considered as an anomaly, right?
Sorry, your voice is cracking.
Hello. Is it clear now, ma'am? Hello.
Yes, please.
Ma'am, that thing that you just explained,
Yes.
can it be considered as an anomaly? Because we can't make like 100% accurate models, no?
Yes, but it
Mm,
should be somewhere near to it, right? Like
yeah, yeah,
if the value is differing too much, then
yeah.
it will be considered as a bad prediction. But it if
Okay,
it is like somewhat near to it, as the first example is there, right? User 808. In that, actual rating is 5.0, but the predicted value is 4.70. So it is like somewhat near to 5.
okay, okay,
So that is the case. If the value is somewhat near to the actual rating, then it can be considered like it has made a good prediction.
okay, 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 ma'am. Thank you.
Oh yeah, sure. So please, like I will just open the code part. Please go through it, and like I hope everybody is clear on this. The output.
Yes, ma'am.
All right. So I'll just open the code part, and you guys can just go through it. Then we will move forward to the other example. Just for 2 minutes, then we will just move to other example then.
Hi, ma'am. Hello.
Yes.
Yes, ma'am. One question. This is the user 557. Item ID 682.
Yes.
Second row.
Yes.
Actual value 2.0, but the predicted value 2.88.
Yes.
What is possible, ma'am? Actual value 5, but predicted value in 4.7 and near. What is
Yes.
second row actual value? Yes.
Because user gave a poor rating, right? So basically it is that the model has done a mistake and it has predicted a much higher value than that. So it is not a good prediction that it has done. So basically the model is getting like it is model's weakness, so we need to identify it and do it again, because the model is performing that way, right? So that is our job to do it and fix it. So it is, you can say
Okay.
that it is some kind of error matrix for RMSE or may for a large set. So basically the investigation about prediction, it has not done well. So we need to improve the model then.
Okay, ma'am. Thank you.
Okay. So now we will move to other one. This is also SVD, and in this we will be doing movie prediction. So in this also a different in this we have used movie rating. So as you can see the data above that has been used. So the rating is still 5, and you can see that 3 is repeated. But in this, the output, as you can see, user 2, the actual rating is 3, but the predicted value is 4.08. But the error is differing by like 1.08, right? So still it is making bad bad prediction. For user 3, movie B is there, that is item. The actual value is 4, but the predicted is 3.93, but still considerable because the error ratio is, we can say, minus 0.07. That is very close. So like still the model has done better and it has recommended. Third is user 2 movie B, and that is actually is 2 point like 2, and predicted is 4. In this the error ratio is very large. So basically the prediction for user 2 on movie B is the worst, suggesting the model overestimated the interest. So basically in this also we need to try other matrix, other evaluation matrix as well. So we need to improve the evaluation matrix. So this is how it is there, as in you can see that the RMSE is 1.3158, and for RMSE that is root mean scored error. That is, so it means that basically that on average the prediction derivate from the actual ratings by about 1.31 rating points. So a lower RMSE closer to 0, it indicates better performance for a model. But in this case, as you can see that the prediction for user 2 on movie B is the worst because the actual rating was 2, but the model predicted as 4, right? So the suggesting model has overestimated the interest. So basically the next steps for this would be like we need to inspect the model behavior for items with high error, and we also need to use more training data or features to improve personalization, and also use different evaluation metrics that would be MAE or precision at the rate K, etc. So please, so please go through the code and output for 2 minutes, then we will shift to other example.
Hello, ma'am.
Yes.
Ma'am, from where we got the screen recording of the lecture, ma'am?
You need the screen recording.
Like, ma'am, lecture recording, ma'am.
Okay, so like please email in support. Like wait, I will give you the ID. Please email and I have a query about that. Just wait a second. I will give you the email address in the chat box.
Yeah, sure, ma'am.
Yeah. Okay. Uh, just wait a second. Please send your query in the email, and they like for the support team, they will surely help you out regarding this issue.
Okay, ma'am. Thank you.
Yeah. So now we will move to the other example. So in this, we like this example is basically based on item based collaborative filtering. So as I have explained, in this basically we are taking again the movie data set. So the ratings are mentioned in this. So at first we will be taking the rating matrix. Then we are going to transpose to get item user matrix. That is done by this. Then we will temporarily like fill nans with 0 for similarity calculations. Fourth would be we will be doing the computation with cosine similarity between items. Fifth would be now we are going to predict rating for user 1 on movie C. So we will be using user 1's ratings on other items and similarity with movie C. So basically get items that user 1 has rated. So we are going to do that. Then we need to compute the weighted average between the similarities. So as you can see this is the output. So basically it predicts the rating of a user given to a like movie, specifically how user 1 ratings for movie C is predicted using cosine similarity between items and known ratings. So like for ratings, like first, as you can see that user 1 hasn't rated movie C. This is what the model is going to predict. So by using item cosine similarity matrix, it is going to predict. So as you can see that the value ranges from 0 to 1. So the higher the value, strong similarity between movings based on the user ratings. For example, movie A and movie B has a very high similarity, that is 0.99. So as I like it is also calculated through the formula that I have shown. So after applying the formula, the predicted rating comes to 3.97. So the predicted U1, that is user 1 would rate movie C would be 3.97. So basically this prediction is also like it is calculated based on the formula that I have shared in the PPT. As you can see that there was no value by user 1 to movie C. So we were basically going to calculate that how would user 1 would rate movie C. Basically it was done by the historical data that was present from before. So we finded the similarity between the movie data sets that user 1 has liked before, the genres, and according to that, the predicted rating for U1 on movie C is 3.97. So we used item similarity cosine. So you can go through the code once for 2 minutes, then we will move ahead to the other examples. Okay, then we will move ahead to item-based collaborative filtering. Like I have one more example. This consists of grocery items. Like so, basically, this is the data sets. So in this also, we're gonna predict for user one that like we are gonna predict user one's rating for butter. So as you can see, the data that is given above. So for this scenario, the predicted rating for user 1 on Butter came to 3.63.
Ma'am, why are we calculating ratings here?
So basically, the model's accuracy is given by that only, right? So we this is as I have explained about it. So basically, item based collaborative filtering is only based on the matrices, right? So we are going to predict. So the model is also based upon like how it is done based on the items. So whatever the items is there, suppose if a user likes it or it does not likes it, so we need to determine that only. That's why we are calculating ratings in this. So the prediction is done, the formula is also for predicting rating only. So we are using cosine similarity function for this. So basically it will also help to prioritize the personalized content also, and it will help us to determine to fill in the blanks in the rating matrix, because in this you can see that, right, for user 1 we are like calculating for button, because in this is null, no value is there, so we need to predict it. So the predicted rating for user 1 on butter is 3.63. in
Okay, ma'am.
in the ppt I have showed a formula as well, right, for this. So for item based filtering also there is a formula, and for user based item based filtering also there is a formula. So basically we are calculating it to determine and fill in the blanks for that, and it is used to personalize user experience as well. So Netflix would be a prime example for it, because if a user one has liked a certain movie of a specific genre, then the similar genre movies keep on popping. So basically, this is calculated and predicted upon that basis only. And item based collaborative filtering, for that would be a prime example, would be Amazon. If suppose you have got a Bluetooth speaker, so then the Amazon also also recommends you earbuds as well, because previously the users has bought them. So based on that history, the model has learned the algorithm in that way. So it like whoever purchases a Bluetooth speaker, so they also suggest the same product to the person who is buying right now. I hope it's clear. Now we will move to user based collaborative filtering. That would be the last example for today. So in this, we are using movie only. So basically, in user based collaborative filtering, we use movie recommendations and things for this. So as you can see that we need to we need to predict user one's rating for movie C. So this is the formula that has been used. And as you can see, the predicted rating for U1 on movie C that came 4.32. So similarity between U1 and U2 is 0.96, and similarity between user 1 and user 3 is minus 0.73. So basically user 2 is highly similar to U1, right? Because likes and dislikes, that both of them, it aligns with it. But U3 is negatively correlated, that means opposite taste. So basically we typically ignore or downweight their input in this. So when the target item was movie C, so the similar users are user 2 and user 3. So the predicted rating came 4.32, and it is calculated based upon the formula. So basically we are checking the accuracy of model in predicting rating based on based on the techniques, that is user based collaborative filtering and item based collaborative filtering. So in this, there are the data is based upon the users, and we are basically calculating the similarity, right? Any questions on this?
Yes, ma'am. Ma'am, another type of recommendation technique in
Sorry, can you come again, please?
another type of recommendation technique like hybrid recommendation technique.
So, like, for there are two types. So, content based filtering and collaborative filtering. So, other one is not there. Only two types of the filtering that is present for hybrid recommendation system as of now, as of what I am aware of. Maybe there are few more. I'll get back to you on this if needed in next lecture.
Ma'am, some example of hybrid filtering.
Hybrid filtering.
Yeah.
Hybrid filtering is itself collaborative filtering and content based filtering, right? So basically, content-based filtering that would be based upon item or user attributes that we discussed today.
Yes, ma'am. As combine of user behavior and item metadata like behavior filtering and hybrid.
Yes. So there are two types, right? Collaborative. One is collaborative filtering. That is
Yeah.
basically based on user item interactions. That is, for example, it would be rating, views, or purchases history. It is based upon that. And the other one is content based filtering. So it is based on item or user attributes.
Ma'am, depending on your data, like using the call filtering.
Depending on what data?
What the data set like a movie recommendation, e-commerce, etc.
That's what I said. For collaborate, like, see, based on user item interactions, the ratings, views, or purchases, then collaborative filtering is used.
Okay. Okay, ma'am.
Okay.
Ma'am, user, it has predicted that user has given 4.32 rating to movie C. It means that the user will watch that movie and likely to give that much rating. It is what it means. Like,
Yes. Like, it has based, what it has done is like based on the previous ratings, like similar to like whatever the user one has rated to, like whatever the movie C is, like that consists of genres. So basically, like it is predicting that user one will likely give this rating to movie C based upon the historical data that was provided. I hope it is clear, right? Or it is not clear, Asta?
yes, ma'am.
So basically, the like how likely the user one will predict the rating for movie C. That's what we have calculated.
Okay, ma'am. So, like, how it's related to recommends how the it will recommend like 4 point. It has predicted rating, right?
Yes.
So it means that the more the rating, the user will like that movie. It what?
So the rating is out of 5. All right. So this is calculated with the formula that was shown in the PPT. So it is like it is the it is you like it has used the formula. Then it has calculated the predicted rating, and the rating is out of 5, as you can see in this. So out of 5, the movie A has been rated like by user A is 5. Sorry, user 1. Movie A is 5, movie B is 4, and movie C is yet to be predicted. So the rating is out of 5. So we need to predict the rating that like the similarity like by comparing the similarity between user 1 and user 2, and then user 1 and user 3. So how similar they would be, and based upon that, the rating is calculated. Because the similarity between user 1 and user 2 is 0.96, but the similarity between user 1 and user 3 is negative. So that means that user 1 and user 3 does not have similar taste, but user 1 and user 2 has a similar taste. So based on that, it is predicted 4.32 by using the formula.
Okay, ma'am. So here we are understanding the user behavior by calculating the similarity between the
Yes.
user based on the rating.
Yes. So basically, in this, like again, I'll explain. See, in user 1 and user 2. So the thing is that the similarity is like in positive, that is 0.96. So that means that both the users have some kind of similar taste, but in like with similarity to user 1 and user 3, that comes in negative. So that means that this like both of them has different preferences. So that's why it is there. So basically we are judging the user behavior based upon this.
Okay, ma'am.
Okay, and the rating is out of 5 point scale only, as we have taken. So in this, like it came 4.32, right? So based upon the interpretation, the model gave 4.32, which is a good recommendation that has been done by the system.
Okay, means ma'am, the both users are similar. So in future, if any movie liked by user A will also be liked by user 2 because they are similar.
Yes,
That's
that's correct.
what we are understanding. Okay, okay, got
Yes,
it.
yes, that's the whole concept of this algorithms what we have studied today. So there are two techniques: user based, collaborative filtering, and item based.
Hello, ma'am.
Yes.
Can I ask a question?
Yes.
Ma'am, it is a compulsory that we should always use the cosine similarity into for recommendation, or we can use any other machine learning algorithms and all. Hello, ma'am.
Yes, I'll get back to you upon this. Actually, I don't have idea about this, but as far as I know, like we will be using cosine similarity only.
Yeah, that's why I'm
Okay.
asking because there are some other ML models like a KNN, and also I want to clarify that.
Okay. Yeah, oh yes, you can use it actually. Yes, you can use it. The Pearson correlation also you can use it, and Jacquard also I have mentioned in the PPT. So I have just given the example for cosine, right? So there are other algorithms also that you can use.
Ma'am, Jacquard and all are the techniques, no? I'm asking for any machine learning models like for linear regression. It is it is used for linear relationship, right? That's why I'm asking. Can we use any machine learning models for a recommendation, or it is a compulsory to use these kind of techniques like a cosine similarity and all distance kind of techniques?
I will get back to you on this in the next session. Then I will have to confirm about this, and I'll get back to you then. All right.
Okay, ma'am.
Okay, I'll get a confirmation and we'll let you know. Okay.
Okay, okay, ma'am.
Okay. Thank you. So I'll be wrapping up the session then. Okay.